Guidelines for finding extrema on a closed interval. To find the extrema of a continuous function f on a closed interval AB, use the steps. Okay, so remember this theorem. If f is continuous on a closed interval AB, then f has a minimum and maximum on the interval. Okay, remember, extreme value or extrema is a absolute min or max. So, assuming that we have a closed interval, these are the steps that we're going to use to find the extrema, the min or the max, on a closed interval. Okay, so first it says find the critical numbers of f in the open interval a to b. Okay, remember, critical numbers are the x values where the derivative of f of x equals 0 or the derivative of f of x does not exist. The x values that make either of these statements true. Evaluate f at each of the critical numbers from the open interval from a to b. Evaluate f at each endpoint from the closed interval from a to b. The least of these values will be a minimum, the greatest is the maximum. So let's go through these steps. So first thing we're going to do, look at this example. Find the extrema on a closed interval. So we have this function f of x equals 3x to the fourth minus 4x cubed on the closed interval from -1 to 2. So first of all, we're going to find the critical numbers. So the first thing we have to do is we need to take the derivative of this function. The derivative of this function is an easy one. It's the power rule. This would be 12x to the third minus 12x squared. Next, we need to figure out the x values where this derivative is equal to 0. So I'm going to take the whole function, set it equal to 0, and figure out the x values where this would be true. So if I factor out 12x squared, I'm going to be left with x minus 1. So when x is 0 and when x is 1, that would make this function equal to 0. So those are critical numbers. Notice that there are not going to be x values where this derivative does not exist. Okay, this isn't going to apply to this function because we don't have x values in the denominator. Okay, so we have our critical numbers. Now let's evaluate our critical numbers. So let's do this. Let's do f of 0 equals 3 times 0 to the fourth power minus 4 times 0 to the third power. That equals 0. Also, let's evaluate f of 1. So that's going to be 3 times 1 to the fourth power minus 4 times 1 to the third power. So this would be 3 minus 4, which would be -1. So basically we've just done step 1, step 2. In step 3. Or no, we've done step 1 and step 2. Step 3, evaluate f at each endpoint. So now I need to do this. Now I need to do f of -1. That would be one of these endpoints. So this would be 3 times -1 to the 4th minus 4 times -1 cubed. This would be 3. This would become +1 minus 4. This would become -1. So this would be 3 plus 4, which would be 7. All right. Finally, I need to evaluate f of 2, which would be 3 times 2 to the 4th power minus 4 times 2 cubed. So f of 2 equals 3 times 2 to the 4th power 16 minus 4. 2 cubed is 8. 3 times 16 is 48, minus 4 times 8 is 32, so this would be 16. So I've done step 3. Now we need to figure out the minimum value and the maximum value. Well, here's my values. So this is going to be my minimum, and this is going to be my maximum, and this is going to be my minimum. That's it. Let's try one more of these. Finding the extrema on the closed interval. So again, we've got a closed interval. Anytime we have a closed interval, we have a guarantee that there's going to be a minimum or maximum. Okay, so the first thing we're going to do is find our critical numbers. So we're going to take the derivative of f of x for this function here, which would be 2 minus, let's see here, this would be 2 thirds times 3x to the -1/3 power. This would be the power rule here. This would go out in front. You subtract 1, you'd have that. So then this would be f prime of x equals 2 minus 2x to the -1/3 power. And we could think of this as f prime of x equals 2 minus 2 all over x to the 1/3 power. So now, to find the critical numbers, we're going to take the derivative, set it equal to 0. Okay, and to solve this, I could move this to the other side of the equation, which would be adding 2 over x to the 1/3 to both sides. And then we could see here, from this point here, the only way this equation could be true is if x were equal to 1. Right? If you plug in 1 here, this would be 1 to the 1/3 power, which would be 1, 2 divided by 1 would be equal to 2. Okay, also, let's try to figure out where this derivative does not exist. Okay, we got to find the x values where this wouldn't exist. So looking at this time we do have a variable in the denominator. So think about an x value where it would make this undefined. Well, that would be at x equals 0. So here are my two critical numbers. So now I need to evaluate f of 1. I need to evaluate f of 0. Those are my critical numbers. I need to evaluate f of negative 1 and f of 3. Those are my endpoints. The minimum or maximums are going to happen at the critical numbers or the endpoints. So let's do this. This would be, so now I'm just plugging that into this function here. So this would be 2 times 1 minus 3 times 1 to the 2/3 power, which would be 2 minus 3, which would be negative 1. Okay, then I've got f of 0. This would be 2 times 0 minus 3 times 0 to the 2/3 power. This would be 0. Then I've got 2 times negative 1 minus 3 times negative 1 to the 2/3 power. This would be negative 2 minus 3. Let's take a look at negative 1 to the 2/3 power. You could think of this as being the cube root of negative 1, but then you're squaring this. Well, the cube root of negative 1, that's going to be negative 1, but if you square it, that's going to be positive 1. So this is going to be positive 1. So this would be negative 2 minus 3, which would be negative 5. Then we've got 2 times 3 minus 3 times 3 to the 2/3 power. So this would be 6 minus 3 times the cube root of 3 squared. Or 3 cube roots of 9. Here we could use a calculator to evaluate this. This is going to be approximately negative 0.4025. Okay, and then finally all we have to do next is evaluate the minimum and maximum. So this is going to be the minimum, and this would be the maximum. So the maximum would be at 0, 0. The minimum would be at negative 1, negative 5.